That was me last night, 3 in the morning. Oh, I can't sleep.
Right triangle trig. Okay, again, like I said earlier, this should feel like review. This whole lesson should be review, but we are going to go through it because the rest of the week and weeks to come, it will definitely get more difficult. Okay, tools. First tool is a tool you learned back in Math 2. You also used it in Math 1. SOHCAHTOA is correct.
Some old hippie came a-hopping through our apartment.
I forgot about that one. Did you remember him giving that beginning of the year? What was it?
Some old hippie came a-hopping through our apartment.
I like it. Thank you. Thank you.
You gotta look out for them old hippies. They're home invaders.
They're always hopping in your apartment.
All right.
They're like their beach buggies or whatever. Beetle vans.
All right. Next one you learned in Math 1. A squared plus B squared equals C squared. Pythagorean's theorem. Good. Next one, we're going to assume that angle C is always 90 degrees unless stated otherwise. Angle C is always 90 degrees unless stated otherwise. For example, what I'm talking about is when you draw your right triangle, however you draw your right triangle, put angle C will be the right angle unless stated otherwise. It doesn't matter up here which one's A or B, as long as C is always your right angle, again, unless stated otherwise.
But what is all C?
What?
What is all C?
Angle C.
I'm
sorry.
What is
no, don't worry.
LC, bro. LC.
All right. And angle A, this, I'm not quite sure where and when you learned this, 6th, 7th grade, 8th grade. Angle A plus angle B plus angle C, the sum of the interior angles of any triangle always add up to 180 degrees. Good. All right, does it matter? Does it have to be a right triangle for that to happen?
No. Not necessarily.
No. Phones put away, please. And we are focused. All right, solve. You're going to see in homework, on quizzes and tests, it's going to say solve the triangle. Right, what does it mean to solve the triangle? I'm going to put in parentheses here. Find all missing sides and angles. Find all missing sides and angles. Bless you. All right, number 1. Before I go any further, I'm going to pause here. I just wrote A equals and that's it. I want to come back up here and talk about side A, side B, side C. Does it matter which one I label A, B, and C once I've labeled my angles?
Yeah, it kind of does.
Which one is side A, which one is side B, or how do you
They're
know?
the ones that aren't side C, which is 90 degrees.
Okay, so if this is angle C, which one is side C? The one directly across. So this is side C. So AB is C. If this is angle A, where is side A? CB. So we use lowercase letters for sides. And if this is angle B, then this is side B. So the sides directly across the corresponding angles. Got it? Angle A, side A, angle B, side B. And again, we use lowercase letters for the sides, uppercase letters for the angles. All right, angle. I just put uppercase A. Should we know also a degree marking there, 72 degrees. This is lowercase c is 18. And if you can't tell that it's lowercase, there's no degree marking on the 18, so you can tell there that it's a side, not an angle. Okay, what I suggest you do first is draw a picture. It does not matter how you draw your right triangle. You can draw it like I did. You can flip it around like this. You can flip it around like this. It does not matter. Just make your right triangle and make sure that which one is C? The 90 degree. Now, as long as you do that, even if your picture looks different from mine, we will end up with the same answer at the end. Okay, I'm going to call this one up here A and this one B. If you want to call it B and then A, it does not matter. All right, I am going to label the given information. This angle A is 72 degrees. Side C is 18. Where is side C? AB, BC, or CA?
Hypotenuse.
The hypotenuse. Opposite the 90. Okay. Now, here is how I want to see your work done today. Are you ready? Did you do your problem? You're going to write this. This will be given. That right there. You're going to draw your picture. And then you're going to write this. Angle A, angle B, angle C. And this is how I want it done from here on out. And then little a, little b, little c. Sides and angles. And we round to 3 decimal places when we do this. Yes, all unit long. How many decimal places? 3. What is that when you're saying like tenths? What is the 3rd decimal place? Thousandths. So round to the nearest thousandths place. You need to know that because on the test it will tell you. Round to the nearest thousandths. And I had a kid one year drop a whole letter grade on his test because he didn't round to the nearest thousandths. Everything was to the nearest tenths. Be careful, read, and what they're asking you to do. Okay. I'm going to go ahead and label what was given to us here, 72 degrees, and C,
C is 18.
18.
Angle C is 90.
Good. Now they didn't give us angle C, but is that a should know?
Yes.
Yes, so that one's going to be the easiest to find every single time. All right. What other, is it easy to find angle B?
Yes.
Yes, can you tell me how?
You can do angle A plus angle B plus angle C equals
Two of your sides.
Good. 72 plus,
angle B. You can do like X.
I'll call it 72 plus 90 plus angle B equals 180. Okay, so she said 72 plus 90 plus the unknown angle B, or you can call it X, is what she said, equals 180. So add and subtract, and you get your angle B. And what did you end up with? No, coincidence, that's just coincidence that those two are the same, but this is a degree and that's a side, so they're not the same. Okay, questions on how we found angle B and C? All right, looking at the right-hand side, do we have enough to use Pythagorean's theorem?
Nope.
Do you agree? In order to use Pythagorean's theorem, I need to know 2 sides to find the third. Do I have enough?
Nope.
No. So what do we use from our tools that we haven't used yet? SOHCAHTOA. All right, so here is what you do. This again is review. You've done this, so I just want to make sure we refresh. Put your pencil mark. It doesn't matter which angle as long as it's not the 90. So cover the 90. You can mark angle A or you can mark angle B. I'm going to mark angle A only because I already have it written in here. But technically, do I know what angle B is?
Yes.
So if I wanted, could I put the 18 in there and use angle B?
Yes.
If you do, you'd end up with the same exact answer as I do at the end. Your work would just look different. All right. I'm going to look for little a first, only because it comes first in the alphabet. But you could find B first if you want. It does not matter. Okay. In reference to angle A, what is side A? Opposite, adjacent, or hypotenuse? Okay, so we label. In reference to A, what is 18? Opposite, adjacent, or hypotenuse? Do you agree it's hypotenuse regardless of where I'm sitting?
Yep.
All right, so looking at your SOHCAHTOA, which one is it that deals with opposite over hypotenuse?
So, sine.
Excuse me. So we do, I'm going to put it up here, sine of, always an angle. Sine, cosine, tangent of an angle. So sine of 18 or 72?
72.
Sine of 72 equals opposite over hypotenuse is A over 18. And do you guys remember how to solve this when you learned this 2 years ago? Multiply both sides by 18. And it crosses out there. Do you guys see that? And then you plug this in your calculator exactly as you see it. 18 times sine of 72. You don't even have to hit times. You can. That's not necessary. The only thing I suggest is you do not put the 18 after the 72. If you do, you have to make sure you close your parentheses.
Can you like go back and explain how you got like the sine 72 and whatnot.
This right here?
I missed that, yeah.
Uh-huh.
I nearly forgot how to do science.
Okay, so we're using sine, which is opposite over hypotenuse.
So you're using that because it comes first in the order?
No, the reason I'm using sine is because I'm looking for A, and I'm only looking for A first because I wanted to. You could have found B first if you wanted to. Okay.
So why don't we use like
Okay, and here's why. And I marked 72 just because it was already there. You could have used angle B. Did anybody use angle B instead? No, no one did. You could, it doesn't matter, but I'm using angle A. So I put my little pencil mark up there. Can you see it, the little dot?
Yeah.
In reference to 72, what is A, opposite or adjacent?
Oh, okay, yeah.
It's opposite, and that's hypotenuse. So I'm forced, because that's opposite and that's hypotenuse, I'm forced to use sine. So that's why I
it's
label
opposite
first.
and adjacent? So like why is it opposite that hypotenuse?
Because 18, you're the one who told me 18 earlier was the hypotenuse.
Yeah, okay.
Because 18 is the hypotenuse and A is the opposite, I'm forced to use sine.
Okay.
When I use B, when I look for B, which I'm not yet, but when I do, what will I use instead? What is B in reference to angle A?
Adjacent.
Adjacent, and which one's adjacent over hypotenuse? So then I'll use cosine. Not yet, but when I get there.
Yeah, but the thing that I don't get is like there's two of them, sine and tangent, which have opposite.
Mm-hmm.
So like
Tangent's opposite over.
adjacent.
And why can't I use tangent? Because that would give me A over B, and I have too many unknowns. Opposite over adjacent is A over B.
Oh, okay.
And I can't have two variables when I'm solving. I need one of them to be a number, so I'm using hypotenuse for both of them.
I think I got it.
Okay?
Yeah.
All right. So what did you guys get when you plugged this in? 3 decimal places. 17.119? 17.119 units, whatever units they may be, inches, meters, feet. Okay, bless you. Now, technically at this point, if you wanted to, could you use Pythagorean's theorem? A squared plus B squared equals C squared. Technically, I typically do not like to use it when I have decimals, but you can. I'm going to use SOHCAHTOA just for the practice. Okay, so I just said it a few seconds ago. I'm going to cover the A now because it's found. I could use A, but I'd rather not use decimals, so I'm just going to cover it. What is B in reference to angle A? Adjacent. And is 18 still the hypotenuse? Yes? Okay, so which one's adjacent over hypotenuse? Cosine. So we do cosine of what angle? The same angle we're using. What is it? 72 equals adjacent, which is? Over hypotenuse, which is? 18. And what do we multiply both sides by here? 18. Same thing, but this time instead of sine, it is cosine. So you type in your calculator 18 cosine and then angle 72 in 3 decimal places. Remember, if you put the 18 at the end and you do this, cosine 72 times 18, is that okay?
No.
No. I'm going to show you end up with a different answer. Where did I mess up? If I type it in the second way, what do I have to do? Close the parentheses before multiplying by the 18. Okay, so it's easier just to put it in the front. All right, what do we get? 5 point what?
562.
562. All right, and I box in all of my answers, and we have solved the triangle. Any questions? Yes?
So the angle doesn't have to match the side that you're using. You can use angle A and side B. Like,
Oh.
angle A and angle
No, no,
B,
no.
side A.
Good question. She's asking, do you have to use angle A to find side A? Is that what you're asking? Or angle B to find side B? No. Pick an angle, and I only picked angle A only because it was already labeled. But technically, I could have come down to angle B, which was 18, and I could have used B to find both A and B. Yeah, so they don't have to match when you're looking. As long as you're labeling your opposite adjacent appropriately, you're good. Okay. Number 2. Little a equals 2 and little b equals 3. Again, you draw your right triangle. It does not matter how you draw it as long as your right angle is C. And I typically put my A there and B there. All right, little a is 2, little b is 3. Do you guys see that that's little a and little b? Opposite. All right. So don't forget on homework, I want it to look, so this will be the given, this is what they're going to give you, and they'll say solve the triangle. You draw your picture, and then you do your angle A equals blank, angle B equals blank, angle C equals blank, and then little a, little b, little c equals blank, blank, and blank. And this is how you're showing your work. All right. Yes. Okay, so I'm going to label what's given. Little a is 2 and little b is 3. Now, did they give us any angles? No, but we know which one.
C.
C is 90. Okay, I'm not going to put that in pen. In pencil. Even though it's easy to find, it is still one that we found on our own that was not given. All right, can anybody tell me what's the easiest thing to find next?
The hypotenuse is root 13.
Okay, you already have the answer. How many other people have this answer? I didn't get it out.
Did you say root 13?
Root 13 is what he said. Can you guys, anybody, he gave me the answer, so can somebody else share with me how you got root 13?
Just Pythagorean theorem, so 3 squared.
I trust your work, but I know you know how to do it, so say it again.
Just Pythagorean theorem, so 3 squared plus 2 squared equals c squared.
Good job. All right, so she said Pythagorean's theorem, 3 squared plus 2 squared equals your c squared. So do that now. 3 squared is 9, 2 squared is 4. Add, square root both sides. And what does it equal? Root what? All right. Do we have enough on this side to use the tool that says all the angles add up to 180? No, I only have one angle, and that's not enough.
I know how to do it.
Go ahead.
Once you just take the inverse side, or inverse angle of like 2.
Good job. Can you tell me what popped out at you that made you remember it from last year or year before?
Well, honestly, nothing about the past. I just looked at it, and then I noticed that if you had to say sine of 8, and it would equal like 2 over 2, and then I figured, well, how would you get the answer from it? I remember the inverse side.
Good job. Okay. So if you remember back in units prior, when we had sine of what angle equals a number, like he said, oh, we use the inverse, and that is correct. So let me walk you through what he's saying. I'm going to find A first, only because it comes first. Right, so I put my dot there at A. Got it? Now, I could use the root 13, but I'd rather not use decimals, so I'm not going to worry about hypotenuse. In reference to A, what is 2? In reference to angle A, what is side 2? Opposite or adjacent? And what is 3? And the hypotenuse is root 13, but I'd rather not use a radical, so I'm just going to ignore it. All right, which SOHCAHTOA, which one is opposite over adjacent? Tangent? So, Justin, you were saying earlier, how do you know which one to use? That's how you know, because that's opposite, that's adjacent. Technically, we have the hypotenuse, but I'd rather not use it.
So you use what is given.
Yes, you look at what's given, you label them, and then you decide, oh, opposite, adjacent, that's tangent. Okay? Okay, so we have tangent of an angle. Do we know what the angle is, or is that what we're looking for?
That's what we're trying to find.
That's what we're trying to find. So tangent of A equals 2/3 or 3/2?
3, opposite over adjacent, so 2/3.
2/3. Okay, I'm not done, but I just want to make sure that everyone understands where I got this from. Tangent of A, I don't know what A is, so I can't call it anything other than A. Tangent of A equals opposite over adjacent, which is 2 over 3. Yes or no? Okay, so what Tyron was saying was that he said, I thought, how do I find this angle if I know the answer? Oh, inverse. Do you guys remember that? Kind of. If not, you're making a note to yourself right now. If you're ever looking for an angle, what special key are you going to use?
Second.
The inverse key, the second key. All right, so I'm going to show you how to write it down first. Do you guys remember that? We did the inverse sine, cosine, tangent before. Of 2/3 equals angle A. So this is how you're going to plug it in your calculator. Inverse tan 2/3. So make a note, a mental note, or write a note in your notebook. When looking for an angle, use the inverse key. When the angle is unknown, use the inverse key. Dominic, need you paying attention? Can you guys nudge him? All right. You were snoring.
What I don't get is like, so you inversed it and then swapped the A and the 2
That's how the inverse works. You swap the x and the y.
Okay.
So these two switch places and you do the inverse.
So the X is, okay.
Uh-huh.
Tan X equals Y, then the inverse of tan Y equals X.
Yes.
So it's the negative first.
Yes, and so the way you play in your calculator looks like this. So you do second tan, you see that little -1 key pops up, and then 2 divide 3. You don't have to close your parentheses. And then equals, in 3 decimal places, what do we get? 33.
Do you have to put the 0?
You do, to show that you went 3 decimal places. And it does continue, right, at 0.06753. If it was just 33.69 and there were no more numbers, then no, you don't need it. But since there are, then yes. 33.690. It's a book page. Do you have the assignment sheet?
Yeah.
The pink one?
So it's in the book?
Yeah. All right. Choices. Do you want to use inverse key again to get more practice, or just use the fact that they all add up to 180, your choice?
Use the fact that they all add up to 180.
Okay. So add and subtract from 180. Go ahead and do that now.
Don't forget to put your degree markers.
Thank you. And I did not write there. All right, what do we have? 50.
6.310.
Thank you.
Do you complicate the 0?
Yes, that was the question that Tyron asked. If it's something like this, and you see, I don't know if you can see it in there, how there's more numbers here, then yes, you have to. If it ended there and that was the last number was 9, then no, it's not needed. Okay, are we good? Okay. Questions on how to solve a triangle? Does it feel like review at least somewhat? Yes. This inverse business, you did this back in Math 2. The end of first semester. You did all this inverse business here. Okay. Number 3. Mm-hmm.
How many example problems do we have?
7.
Oh.
Just kidding. Sorry. No, we don't have 7. That's good. That means it was fun and exciting. It was so fun. You didn't realize how.
We have good laughs, okay? You know, that's it, Scott. We've had good laughs, though.
This is our last one. I told you I was kidding.
Why didn't you humble?
You like whispered it, though. You're like, we have 7 more, loser.
Yeah, before you said there's 7, then you cut down to 5.
All right.
A 20-foot ladder leans.
I thought that was like a 20-feet ladder.
A 20-foot ladder leans against a house. This is a typical trig.
And it falls over and wrecks the fence.
And it does not. Oh, yes. Those. Okay, remember that in math too? The shadow and the tree, and the person standing next to the tree,
has a shadow and the other tree has
and the flagpole, and
Yeah, or the person standing next to the tree is like 4 feet tall.
So a 20-foot ladder leans against a house.
a house. This is actually.
Hands on the very top step when it says warning, do not stand. It falls off.
No, then Jimmy eats in and out burger, then calculate the density of the sun.
That's like physics.
It's an angle.
That's how camel problems too, so.
Yes, I know the sun is this dense.
A 20-foot ladder leans against a house. Its angle of elevation is 50 degrees. Period. Find the height from the ground to the top of the ladder. All right. I definitely need to see a triangle. I don't need to see, I am going to draw the house. I mean, a basic house, but I don't need to see like the windows and the curtains and the door. I mean, you can, and the dog and the, yeah. You don't even have to draw the house. I just need to see the right triangle. So there, if you just draw that, that is enough. I draw it so that you can get a visual. What?
That's a pretty
I'm
nice
just
ladder
saying
right
this.
there. That's a very stable ladder.
What? Why are you guys making fun of my ladder?
Because like I'm gonna eat you know what, man, it's gonna fall down.
It's so flat. Like I should have put it up higher.
Yeah, like it
you
should have been
always
at like
angle.
more intense. Like,
If it's way out here and it's sticking way out the back, you get a shorter ladder.
It's.
I'm not even sure how to see it up.
It's like physics does not apply to me.
Oh,
Like
goodness.
the house fall.
Where's my little fake ladder? I have a fake ladder over there somewhere.
Fake ladder.
It's a little wooden one. You guys have never seen it?
Oh, I saw it at one time. I remember.
Yeah, it's over
Yeah,
there
and then it fell
somewhere.
down.
This is for the ladder against the tree
I
problem.
All right.
It's like a 16-foot 8 range.
Okay. Don't judge my ladder.
It's too late, it's already.
All right. A 20-foot ladder. Where does the 20 feet go? On the ground, on the building, or on the ladder?
On the ladder.
On the ladder.
The hypotenuse.
Okay. Oh, yes, hypotenuse. I'm going to put my right angle, and all buildings are perpendicular with the ground unless stated otherwise. Its angle of its angle of elevation is 50 degrees. Angle of elevation is always inside your triangle at the ground. So bottom or top? Okay, I will tell you this. Angle of depression is always outside. It's always like this. It didn't ask us for that, but angle of depression would be out here. Do you see that? It's never inside, it's outside. Keep that in mind.
You're depressed once you get outside.
Oh man, I'm depressed when I sit inside watching The Office all day.
All right. So the question then is, find the height from the ground to the top of the ladder. Am I looking for the base here or the length here on the building, on the house?
You're looking.
Find the height from the ground to the top of the ladder.
So top is this way, not
See
that
that?
way. It's like find it from the top of the ladder, or like the top of the ladder.
This is the top of the ladder right here.
Oh, I get it. So you're gonna.
And this is the
find
ground.
Your other angle, and then you're gonna use that angle to
We
find
got a lot going on.
We don't have to find the other angle. Could we just use 50? If you wanted to, could you use the other angle?
Wait, so
Of course.
How do you calculate the angle of depression? Is it like
There are tools. There are tools too. Well, right now we don't need a tool. The angle of depression is 50 because of the Z shape. Do you see that?
Yeah.
So the angle of depression is 50. We
Oh,
know
it's like a
that.
square if the
Yeah.
it's even. So okay.
Parallel lines cut by the diagonal.
I feel you. Wait, so with the
But it's
angle
not-
at
it's
the
not
very bottom
needed.
be 40
Ah.
versus
What was that?
those? So with the angle at the very bottom left be like 4? No, that'd be 40, right?
Up here would be 40.
Yeah. up there.
Yes.
And then
We don't need it, but is it good to know? Should we know it's 40?
Yeah.
Yes. Now, if you wanted to, could you use the 40?
Yeah.
Yes. I'm going to use the 50 only because it's there, and I like it. But and I challenge some of you to use the 40 instead and see if we end up with the same answer. Okay, so up here's the 40, and your labeling is going to be different from mine. Okay, if I'm looking for H in reference, bless you, in reference to this angle, what is H? Opposite, adjacent, or hypotenuse? Opposite. What is the... Oh, stop. But usually it's C, not H. What is the 20? Opposite, adjacent, or hypotenuse? Okay, that looks like it says hop.
That's a hypotenuse.
Hypotenuse. Okay. Which trig function, guys? Which trig function is opposite over hypotenuse?
The sum of
Cool one.
So, sine. All right, pause really quick. Any of you using 40 instead?
Yes.
Okay. If you're using 40, this would not be opposite for you. It would be what? Adjacent, which means you're using cosine. So your work will look different, but answers come out the same. Please stop. So sine of an angle, what angle am I using? 50 equals opposite, which is H, over hypotenuse, which is 20. Because it's height. But you could use A or B or elemental P,
What about
X,
Z?
Z.
Man, that's a big triangle.
You gotta put the line
Solve for
on
stick
it
figure.
too.
What was that?
You gotta put the
Solve
line
for stick figure.
Yes, I do that on mine because for that reason. All right, so I multiply both sides by 20, cross out, and then you plug that in your calculator. 20 times sine of 50. 20 times sine of 50. 3 decimal places. What do we get? 15, 3, 2, 1,
I got 0.9.
0.
I'm more precise with what
Is it 0, 3, 2? So 3, 2,
Yeah, it's 8, 8.
I mean, 0.9.
3, 2, 1. Yes. Hustle. All right, and this is feet. Okay.
That's very odd.
Okay.
It's an odd height,
Are we good?
You know what? It's okay.
All right.
Height is like, you know.
especially for my picture because I drew it like if it was like someone walking up onto the roof. So it's like all the way at the top. So the house is technically 15.32
Feet high.
Rich that house, dude. No, dude, like one story's like 10 feet, bro.
Okay,
What are you talking about, bro? That'd be no fun.
guys.
They got tall ceilings, bro.
You guys need to stop. All right, little bubble at the bottom. Bubble.
That's a cloud.
Okay, cloud. Draw your cloud.
Man, bubbles are like spherical, man.
This is the first day back. Give me a
Okay. How's that a cloud if it's on the It's a bush.
It's our thinking.
It's a shrub.
It's your thinking bubble.
It's your thinking bubble.
Dude, that one
That's
actor,
really big.
That one actor from Empire like tweeted, "How come bubbles aren't like pyramids or like triangles? How come they're spheres?" And then he's like, "How come 2 squared equals 4 when 2 times 2 equals 4?" It's like
What?
Like he's like, no, look it up. That guy actor from Empire, like he tweeted that and he got like roasted like so hard. You remember that?
I like to my bottom corner
It's
of
like, how come bubbles aren't cubes?
Okay. Shh, we're listening.
Real questions.
Okay. Now, this is just a what if. I don't remember if these come up today or tomorrow, but I just want to make sure you remember. How is this different from the last 3 we've done? Look at where your variable is at.
X.
Yes, the variable in the denominator
Denominator is X.
instead of in the numerator. Do you guys remember how to solve this?
Under, so it'd be like,
I will. I just want to see if you guys remember.
don't you use like the 1/18 as opposed
You're right.
to
Oh,
18?
Is this the side?
multiply the x and
Would you
divide by
multiply
the
x
sign.
both sides and divide the sign?
Okay,
35?
here's what she said. She said multiply x to both sides just like we've been doing. She is correct, so x goes away to the other side. But when you have it here, are you ready to plug in or is there still another step?
There's still another
So this one has, please stop, this one has an extra step. So be careful when your variable's in the denominator. When you multiply to the other side, you're not done. You still have an extra step of dividing to get x by itself. And so would you plug it in your calculator differently? Yes, instead of times, you would hit what? Divide. 18 divide sine 35. Can you guys plug that in? 18 divide sine 35. Again, yes.
If you're dividing it, is it technically also the inverse?
No.
No?
No. Okay, so what do we get? 13, is it 13? Yeah, 31.
31.382.
All right, and again, I just wanted to go over this. Came from no particular problem. It was just made up numbers just to remind you when you come to this problem on homework, when you have variables in the denominator, how to work through it. Got it? Questions?
I drew a little bush on my little lawn there.
And you put that in the bush?
Yeah.
I like it.
Make that house